Hi everyone, I'm Regine and I'm going to discuss to you about machine learning. So what is machine learning? It is the study of computer algorithms that improve automatically through experience. Machine learning enables IT systems to recognize patterns on the basis of existing algorithms and datasets and to develop adequate solution concepts. There are two types of machine learning. First is the supervised machine learning and second is the unsupervised machine learning. Next is the process of the supervised machine learning. First, we're going to have a data set. Then, we're going to divide the data set into two subsets, which is training data and test data. In applying machine learning algorithms, there are commonly used machine learning algorithms. Example, linear regression, logistic regression, decision tree, naive-Bayes, and other machine learning algorithms.
I'm going to show you the machine learning implementation using the pima-indians-diabetes dataset. Let's start by selecting File and clicking the New Notebook. Then we rename the file to pima-indians-diabetes. So here, let's rename it pima-indians-diabetes. So after that, we will import the pandas to read our data from a CSV file and manipulate it for further use. Import pandas as PD. Then we will also use the numpy to convert our data into a format suitable to feed our classification model. Next is we'll use Seaborn. And Matplotlib for visualizations. Matplotlib. That pyplot as PLT. Matplotlib inline. Then we will then import logistic regression algorithm from sklearn. So from sklearn that linear model import logistic regression. So there's no space here. Then logistic regression algorithm will help us build our classification model. Lastly, we will use joblib available in sklearn to save our model for future use. So from sklearn that externals import joblib. So let's copy the code here. Paste. Then we will run this code. So now we can choose file, the CSV file. After it is done, let's code the df equals pd dot read csv. Then let's copy the file here, the name of the file, paste, then df dot head. So this code here will read our dataset, and we use head function to show the first 5 records from our dataset. So let's try to run this code. So here, the following features have been provided to help us predict whether a person is diabetic or not. The outcome is 0, which is non-diabetic, and 1 if diabetic. So to make sure that our data is clean or has no null values, we will type df.info, and this will show the results. So here, there is no non-values. So after that, let's explore our dataset by finding correlation of every pair of features and the outcome variable and visualize the correlations using a heat map. So let's type core or correlations equals df dot core print core sns dot heat map core x tick labels equals core dot columns y tick labels equals core dot columns. So that's it. Let's run. So now here we can see in the heat map that brighter colors indicate more correlation. As we can see from the table, here the table, and the heat map, glucose levels, age, BMI, and number of pregnancies all have significant correlation with the outcome variable. Now we will divide our data into training data and test data. The data set consists of record of 767 patients in total. To train our model, we will be using 650 records. We will be using 100 records for testing and the last 17 records to cross-check our model. df-train for the training dataset, df 650. Next is the test data, df 650, 750. Then df check equals df 750. Next, we will separate the label and features for both training and test data set. So train label equals np.as array df train class variable for outcome. Train data np.as array df train dot drop. Let's copy this one. One for the diabetic test label np.as array df test class variable for outcome. Test data np.as array df test dot drop class variable or outcome 1. Lastly, we will normalize the data such that each variable has 0 mean and standard deviation of 1. So means is equals to np dot mean train data axis equals 0. Next is TDS equals np dot standard deviation train data axis equals 0. Then train data equals train data minus means divide standard deviation. Test data equals test data minus means divided by standard deviation. Then we will use the logistic regression. We create an instance called diabetes check and then use the fit function to train the model. So diabetes check equals logistic regression diabetes check dot fit train data train label. Next, we will use our test data to find out accuracy of the model. Accuracy is equals to diabetes check dot score test data test label, then print accuracy equals accuracy 100 times 100. So that will be a percentage. So let's try to run this code. So now the result is 78%. We will save our trained model for future use using joblib dump diabetes check means standard deviation diabetes model pkl. So here it is. To check whether we have saved the model properly or not, we will use our test data to check the accuracy of our saved model. Diabetes loaded model means equals joblib dot load diabetes model dot pkl. Accuracy model equals diabetes loaded model dot score test data test label. Print accuracy equals accuracy model times 100 So let's run this code here. The accuracy is 78%. We will know if we save it properly when there's no change in accuracy. So they are the same. In making predictions, we will now use our unused data to see how predictions can be made. We have our unused data in dfcheck. So let's write this code print dfcheck dot head let's run this code. So this is the result. We will now use the first record to make our prediction. So sample data is equals to df check 1. So we will prepare our sample data features equals np.asArray sample data that drop class variable or outcome 1. Sample data features is equals to sample data features minus means stds. And for the prediction probability equals to diabetes loaded model that predict sample data features prediction equals diabetes loaded model that predict sample data features then print probability prediction probability print prediction prediction. So now let's run this code. So here it is. The first element of array prediction probability 0.440 is the probability of the class being 0 or non-diabetic, and the second element, which is the 0.559, is the probability of the class being 1. The probabilities sum to 1. As we can see that the 1 is more probable class, we get 1 as our prediction, which means that the model predicts that the person has diabetes. So, that's it for our video. Now you have created your first machine learning implementation Python program. Thank you for watching and please subscribe to my channel.